In this session, we will be studying about changing the size of the image, making a smaller image bigger and a bigger image smaller. All the traditional kinds of transformations that we have seen so far, the basic transforms, all are working only based upon the same input and output sizes. This is one of the big drawback for image transforms using basic functions. Okay, so we have so much of applications with respect to changing the size of the image. Among that, we have two things. One is interpolation, making a smaller image bigger, and decimation means making a bigger image smaller. One example application for interpolation is, that is making a smaller image larger, is that connecting to an output device like a printer or a change in the computer screen and so on. Suppose you have a projector and you wanted to project a same image to a larger size, you may need to have some kind of interpolation transforms, image transforms. Okay. The other type is called as image reduction or decimation, where you are reducing the bigger image to a smaller size. So in most of these cases, we'll be having some kind of applications, right? The first one is that it can save the storage, that's one point. It can speed up the processing also. You wanted to change an image, you wanted to identify something. In computer vision applications, there might be situations where you need to understand what the image contains, right? There will be a big screen and a very small elephant in the image. Okay, there might be images where you have a big elephant alone, but you need to identify that both are elephants. Okay, these are all AI deep learning applications. Write down image interpolation, making images larger. What is interpolation? It is the process of upsampling an image, upsampling, upsampling, upsampling an image, in brackets, increasing its resolution, by using known pixel data, to estimate values at new unknown locations. You have a pixel data here. This has to be converted into 2 or 3 pixels in the larger image, right? So the location at the larger image is unknown to you. So the basic concept, continue, the basic concept. Think of it as filling in the gaps. So here, as I told you, You are filling certain gaps. You are enlarging it. When you stretch an image, when you stretch an image, you create new pixel positions. When you stretch an image, you create new pixel positions. Interpolation uses a mathematical formula. Interpolation uses a mathematical formula called a kernel. So it is a kernel. Okay. To decide what color new pixels should be based on their neighbors. Interpolation uses a mathematical formula called kernel. Kernel, kernel, to decide what color those new pixels should be based on their neighbors. So, listen here. You have a small image, you have a big image, you have new pixels in the big image. Okay, so we use a formula to determine what should be there in the newly created pixels. That formula, that mathematical formula, is known as kernel. Okay, all of you understood? Anybody who did not understand? Interpolator, we have two types of interpolation. One is called as the linear interpolator. Here we are making this as bigger. Interpolation means you are increasing the size of the image. Now how you are going to increase the size? First thing is that whenever you increase the size, you have so many empty pixels that you have to fill. How you are going to fill that pixel? What is the mathematical formula you are going to do or you are going to use so that you are capable of filling the empty spaces and making it bigger? This type is called as linear interpolator, wherein kernel is the operator with which you are going to do the mathematical operation so that you will get the output. Okay. So when you use piecewise linear curves, you call it as a linear interpolator. A linear interpolator. Two types of interpolation we'll be learning. First one is called as linear interpolator, where we will be interpolating piecewise linear curves. Is that okay? The next type of upsampling or interpolation, we call it as cubic B-spline. It's a specific type where it's a kind of linear only, okay? Where the approximating kernel does not actually pass through the original input data point. So the operator is developed by convolving a linear tent function that is called as a linear B-spline with itself. So in today's lab, the next 2 hours, in today's lab, I will be showing you convolution operation and correlation operation with an image. What do you understand by correlation? The relation of something with itself. How I am related to myself. That is what is called as correlation. In mathematical terms, you have a time variant object. The relationship of that same, mathematical relationship of that same variable, which we call it as random variable, with itself at a different point of time. Okay, so we'll be considering our images to be waves, and we'll be doing that in this particular time. So coming back to interpolation, interpolation is of two types. The first type is called as linear interpolation, and the second type is known as cubic B-spline interpolation. Upsampling. Upsampling always means, denotes increasing the size of the image. So we have seen upsampling, now we are going to see downsampling. In other words, it is called as image decimation. Interpolation will be used to increase the size, while decimation will be used to reduce the resolution. So we pass high frequency components in interpolation. In decimation, we pass low frequency components. Okay. High frequency components in upsampling, low frequency component in downsampling. So we are not going in depth about downsampling or decimation. We'll just understand the fundamentals. So geometric transformations. So when you do geometric transformation, it is not that you are simply changing the pixel values, you are also changing its position, or there is a change in spatial frequency of your image. Okay, so there is a difference between geometric transformation and point operators. So what are the transformations? Parametric transformations. Okay, global deformations controlled by a few parameters. Inverse wrapping. Okay, you're making things different from what it was in the original sense. Okay, so you know a position and you know that the things are being changed. You wanted to condense that position into one particular position, one particular type. It's a type of geometric transformation. So basically what we need to do, or what we need to understand, is that we need to make some kind of transformations to the images. Different types of transformations are there. One among them is how you are going to change the geometry of the image. Mesh based wrapping. So in computer vision, we will be doing some interesting projects, like you have an image and you want to make that person smile. You have a photo of somebody who is very angry. You want to change that photo in such a way that this person is smiling. So what we have to do, we have to make some complex changes, right? You have to devise, learn how this matrix is working in different angles. So this kind of wrapping means you will be changing the position of every pixel in such a way that there is a change in the overall outlook of the image. That is called as mesh based wrapping. What we do is that we define sparse set of control points or a triangular mesh over the object. You select certain parts which you need to change. feature-based morphing. So morphing is another type of wrapping where we'll be doing some more interesting operations with image matrices. Okay, that's called as morphing. Morphing is done by wrapping, cross-dissolving to create a smooth animation between two different images. So we'll do these things in practice. We'll do some experiments in the lab using our OpenCV library in Python, which is very easy for you. But the problem is that when you are using the library, you know the input, you know the output, but you do not know how really the transformation has happened. So, in our subject, which is theory come practical, in theory, we will be learning the logic behind how it has worked, how the transformation has been done. Like, for example, you have seen how grayscale it is converted, right? You have seen an example. We have done that in our last experiment, experiment number 2, where we have converted an RGB colored image into a grayscale image. The image matrix is converted into completely zeros and ones, right? So that is the way you transform it. We learned how the transformation has happened also. But here also, in morphing and other cases also, we will be understanding that the transformation is being done, how the transformation is being done. In practicals, you will just run a command and you will get the output. You don't know what is happening behind that. How morphing is being done? What are the steps done for morphing? We call it, I just put the title as morphing pipeline as it is given in your standard textbook. So these are the different stages for morphing. Correspondence, you're selecting the area where you need to do the morphing, which is the part of the image that you wanted to make changes, and then you're selecting the time frame and you're converting that into a particular set of pixels into an intermediate shape, but still you have so much of mismatch, so that we require blending where you mix the both the wrapped images, and so we make necessary weights and bias changes. We'll be learning some fundamentals of deep learning in our course. I will be teaching you certain parts of deep learning with certain kinds of projects also. I can also give you some case studies. So I told you that there is some things to be done now before you complete the course. Among that, internal components, one more component is a case study. Case study, I can give you an interesting case study. If you are able to do the project and give me the results, you will get marks for that. If not case study, you can have seminars. There are so many other options also available. Okay, and as far as our time limitations are concerned, I don't think it is possible for us to conduct seminar for all of you. So there will be some case studies, some mini projects, some industry projects, and so on. Okay. So that's it. We have studied the basics of imaging now. We have almost completed all the basic imaging techniques. So what are the things that we have seen? Can anybody recollect? We began our lectures with geometric perspectives. What are lines, what are curves, and so on. It's like a revision which will help you to get your internal exams cleared much easily. So we have geometric perspectives. Then what was the next topic we have dealt with? Image transformations. Transformation means how an image can be converted into another image. Traditional transformation methods, wherein you can change the color, when you can change the aspects and so on. Now, I can give you a very small exercise. If you are interested, you can do that. You can take the photograph of any of your friends or yourself and change the color of shirt or the dress, whatever he or she is wearing. Can you do it? How you will do it? There is no change in the size of the image. There is no interpolation or decimation or anything. Okay, just a very simple, ordinary transformation. This can be done very easily. And I can tell you that last, I took a large session on entrepreneurship, right? You can start your own firm where you can do this image processing. We can restore images, spoiled images. So many other options are available. Similarly, we can do image transformations itself as a, you have a good demand for this. It's not that it's very easy. But now we have built-in softwares and applications. Most of the built-in softwares and applications do it automatically. Advanced softwares like Photoshop and so on, they have also integrated AI into their software. So now it's much more easy. You can simply select, you can change all these things. All these transformations are now done now very easily. So we have two types of images. I told you, static and vector images, right? Vector images are those which do change its shape and pixel when you interpolate it or when you change it. And then we have seen the mathematical foundations, Fourier analysis, and what is meant by DFT, discrete Fourier transform, and then fast Fourier transform, so on. So this is the foundation for your computer vision course, the very basic, and I've taken enough time, and I believe that I've done it very slowly, so that the entire thing is compressed and is easily understood for you to do some advanced work. If you are not able to understand the foundations, you may not be able to understand what is being done in future. If you don't know integration, you cannot do Fourier transform. The same way, if you have not understood the fundamentals, whatever I've taught you so far, it might be very difficult for you to understand the upcoming chapters. So, you can revise through your notes and you can ask me any queries, whatever you have. I have shared with you the question answer format answers for you to study for your exams. I believe that is going to be very, very easy, and I am not focusing on the exams as such. My focus is more on your understanding. I want you to do projects. I want you to understand the concept much more than exams. So that's the reality. Without that, you cannot get into any kind of good jobs. You cannot get into any kind of build your career without having that strong knowledge. So in that case, you can approach me for any kind of support, and labs will be open on all holidays also, evenings also. I want you to come out with interest and do certain kinds of projects. So any questions in the first part of whatever we have seen so far? If you don't ask me questions, I will ask you questions. What do you want, me to ask you or you to ask me? If you don't ask me, I should think that you have understood everything. To be very frank, I myself have not understood everything. There is so much of things that we need to learn. There are so much of things that I also have to learn. So I would like an interactive, collaborative method of learning where I will also be learning from you. You will also be learning from me. But I can show you the path, I can guide you on what are the things that you have to do. Yes, ask me.